So, good morning, students. We'll continue with topic number 7, which is Building Information Modeling BIM in Project Management. So, use of Building Information Modeling, that is BIM, in a project management. BIM, Building Information Modeling, has been revolutionizing the AEC industry in terms of economic and technical viability over the past few years. The advantages of the long-term application of BIM can be leveraged most efficiently in the field of project management. The need for management of an asset is a continuous process from inception to demolition, a true cradle-to-grave cycle which involves handling large volumes of data, handling a lot of responsibilities, and so on, for which BIM is the one-stop solution. Project managers need to embrace building information modeling, integrate the BIM information, and reap the maximum benefits out of it for effective project management. So there are two broad aspects of BIM which enables it in facilitating the project management. So BIM facilitates, the first one, BIM facilitates IPD. IPD is an integrated project delivery and it is a proven method when it comes to project management. An integrated project delivery plan which brings together different disciplines and efforts and integrates all parties including project managers, designers, engineers, systems and practices under a single umbrella, creating a win-win situation for all the involved personnel. When IPD and BIM are used in conjunction, the expectations for the project to be completed successfully are increased. BIM seeks to facilitate the exchange of information between all parties to a construction project, which the goals of reduced costs and error and redundancy. So BIM is an effective tool for combining the detailed information available from all parties into an intelligent integrated model, which in turn improves the productivity of a project team. The technical aspects of BIM. BIM, Building Information Modeling, has some sophisticated technical aspects which can greatly facilitate project management. The quick summary of which is given below. First one, class detection. The inconsistencies in the geometrical designs of the various disciplines of a building is the most commonly seen problem in an AEC industry, that is in a construction industry. So this happens because of an overlap between the different plans. The only feasible solution for this issue would be to use BIM and bring the plans together in a cloud and detect any discrepancies and make the necessary changes. Number 2, constructability. Building information modeling provides a platform to carry out constructability reviews and monitor constructability. Number 3, building information modeling allows for a better analysis. BIM allows engineers and designers a better visual analysis of a building and facilitates better decision making. Starting from the energy consumption details to optimum lighting conditions needed, BIM helps find better solutions such as changing materials and orientation, mass and space, etc. for every problem. 4D and 5D modeling. One of the unique features of building information modeling can offer is 4D and 5D modeling. A 4D model allows an engineer to evaluate the progress of a construction project and have a clear understanding of the project phases. 5D BIM models allows cost evaluation of a project and can help in determining the lowest cost solutions. Essentially, building information modeling BIM facilitates simulation of various alternatives for a construction project and helps project managers and executives to reliably predict the consequences of their decision. Next, quantity takeoff. Quantity takeoffs available in a BIM model can be of assistance to the project teams and managers in analyzing their decisions and facilitate a clear and reliable insight to various alternatives in the design phase or even throughout the project life cycle. Since there is a possibility of integration between the BIM model and a database containing cost estimation, an accurate estimation can be obtained faster. Next, the advantages of a BIM project. First one, improve collaboration and control among project stakeholders. Number two, improve project quality. Number three, faster delivery options. Number four, cost-effective method. Number five, reduce wasting of resources. Number six, maximum revenue and new business opportunities. Building information modeling, apart from being a great tool of assistance in technical aspects of construction, it can also be used as an effective project management tool. The technical aspects of BIM such as clash detection, 4D and 5D modeling, quantity takeoff, etc. can be very useful for project management. So it is for these reasons people who wish to pursue a career in project management should have a clear understanding of how to use BIM tools in a project management. Building information modeling consists of several aspects like demolition, operations and maintenance, construction logistics, construction in 4D and 5D systems, fabrication, documentation, analysis of the design, detailed design visualization, conceptual design, programming and renovation. Disadvantages of BIM. Incompatibility with partners. BIM is not yet universally used among construction professionals. There is always the possibility that one of our partners or subcontractors may not use BIM and may not be able to use your models as well. Number two, legal issues. The legal ramifications of using BIM software have not yet been extensively tested and be settled alone. Number three, cost of software. BIM software requires a substantial investment in new technology. The advantages usually make the investment worthwhile, but only if the software is used to its full capacity. Next, lack of experts. The relative newness of BIM means that there are limited numbers of experts working in the field. So, our software purchase may require an additional investment in training and education. The future of BIM. Because of its clear benefits, BIM is definitely here to stay. So it has defined goals and objectives that are clearly beneficial to all those who work their way through the levels. Undoubtedly, the future of construction will be even more highly collaborative and digital with BIM. And as the BIM becomes increasingly more sophisticated, 4D, 5D, and even 6D BIM will start to play a part in this process. Furthermore, around the globe, there is an attempt to reduce waste in construction, and much of this is attributed to supply chain inefficiencies, clashes, and reworking. By working collaboratively in a BIM environment, all of this becomes much less likely, setting the stage for a better tomorrow. So that's all for this lecture. You can give your attendance in the chat box. Thank you.
BIM, or Building Information Modeling, has been making headlines across the construction industry for some time now. You might have read about it in construction magazines or heard about it during engineering or architecture conferences. Some of you might already be using BIM for your projects. We thought it would be a good idea to make a short video about what exactly building information modeling is and how it is useful for engineers, architects, and construction professionals. To explain the video, we have used simulations that were kindly provided by the cloud-based simulation provider SimScale. Let's start with the basics. What exactly is building information modeling, or BIM? In simple terms, BIM is a digital representation of a building's physical and functional properties and characteristics. BIM goes further than just the building's physical appearance and includes information about every component that goes into a project. This helps the designer, whether it's an architect, engineer, or construction professional, to create and design more effectively when compared to other tools on the market today. Every component of a building is essentially a BIM object. This means you could take a window, a door, or an HVAC system as an example, and the file will tell you the product's properties, like thermal performance, its physical characteristics, a graphical representation of what the product actually looks like, product's functional data, allowing the user to manipulate the object the way it was intended to be used. So we can say that BIM is first and foremost a process, but it's much more than that. BIM is a 3D modeling based process that provides architecture, engineering, and construction professionals information and tools to efficiently plan, design, construct, and manage buildings and structures.
Unfortunately, most people who call themselves business owners are actually not business owners. In reality, they are self-employed. And yes, there is a difference between the two. A self-employed person can call himself a CEO. But if this person does not show up for work one day, the whole business goes for a toss. Business is too dependent on this person. A real business owner, on the other hand, gets to decide his schedule. If he wants, he can work only for 6 hours a day. If he wants.
The essence of the BIM process is that it enables the creation of virtual 3D models that can be explored and manipulated, making it easier to understand the relations between spaces, materials, and systems. A database generates a 3D image and creates building plans. Thus, the BIM process can build, view, and test a structure in 3D. These abilities allow revisions and the assembly of accurate details. The detailed data permits design, clash detection, cost, and scheduling. Each of the stages of design and construction benefit from its involvement in BIM. The most known BIM software solutions are Revit, Navisworks, Autodesk BIM 360, SketchUp, as well as ArchiCAD and Vectorworks Architect. As technology continues to advance, computer-aided engineering, CAE, software is also becoming part of the construction industry. CAE, also called engineering simulation, is being used by engineers and architects to predict wind loads on buildings, ensure pedestrian comfort in urban areas, validate HVAC systems, control air quality and contamination in clean rooms, laboratories, or underground spaces, predict smoke spread, and optimize thermal comfort. Although not usually integrated with BIM software yet, simulation tools are becoming more and more accessible through cloud computing. One example is SimScale, the world's first production-ready software as a service application for engineering simulation. By providing computational fluid dynamics, or CFD, and finite element analysis, FEA, SimScale has moved high-fidelity physics simulation technology from a complex and cost-prohibitive desktop application only available to experts in large companies to a user-friendly web application accessible to any designer and any engineer in the world via a pay-as-you-go pricing model. Here are a few applications. HVAC system. This video shows the comparison of two ducting designs that were simulated for an inlet velocity of 5 meters per second with the SimScale platform. The blue region on the velocity bar represents the low velocity region, while the red region represents the high velocity region. The first design is an unoptimized one which has sharp angles, while the second design Optimized is a more curvy one. Pedestrian wind comfort. The Flatiron building in New York generates very strong winds. The building splits Broadway at Fifth Avenue and sits at the end of an open corridor created by Madison Square Park at the north. At this location, winds tend to be very high. In the case shown, the wind flow direction is from the north, but slightly aligned with the Broadway street. This produces the most interesting effects as the flow encounters the unique front shape. The animation kindly provided by SimScale shows the flow speed, where the red color shows the higher flow speeds. In these conditions, the wind gusts reach the front leading edge / cone shape of the building that creates accelerated flow and vortices on the Broadway and especially Fifth Avenue side. Wind loads on buildings. We can see the main effects of the structure optimization in this animation that shows the flow physics at 3 different cross sections along the height. Close to the base height level, the area is the largest, and so is the weight behind the structure. But the corner softening helps to avoid strong vortexes. At mid-height, the cross-sectional area not only decreases, but also changes between symmetric and non-symmetric form. In this animation, a non-symmetric section is highlighted that shows non-coherent vortex shedding. This helps to spread out the frequencies along the height and avoid a single dominant oscillation. At the very top, the wind speeds are the highest, but as the cross-section area is rather small, due to tapering, the forces are thus small also. Combined together, the structure is very well optimized with wind loading and is effective in taming the wind. Let me tell you a little bit about SimScale. From CAD upload to post-processing, the entire simulation process with SimScale happens in a standard web browser. Being cloud-based, the platform eliminates the hurdles that accompany traditional simulation tools, such as high installation costs, licensing fees, deployment of high-performance computing hardware, and required updates and maintenance. With over 150,000 individual users worldwide, SimScale has become an integral part of the design validation process for thousands of successful companies worldwide, such as WSP, Thornton Tomasetti, Arup, L&T, or Acceptance Group. The platform is used by engineers, architects, and designers who want to easily test and optimize their designs early in the design process, thus also reducing the number of physical prototypes required. SimScale is determined to make engineering simulation more accessible so that everyone can design better products faster and cheaper. To that end, it provides a free community account which can be created in 3 minutes, and many learning resources from thousands of public projects that can be copied and used as templates to weekly webinars, courses, and tutorials. Give it a try by following the links in the video's description.
You're on. During the early design stages, we have a kickoff meeting, sharing the knowledge with the owner and with the guys, the clients, basically. Doing a first step to design, try to help them design the passive requirements, the passive function of the energy performance, and then the energy performances. And then developing a second energy monitoring, and then coming to the final step. So this service is turned into different steps, which increase tremendously the quality. It costs a bit more if you do it in the standard way, but the results are much better. Another way that we try to implement Lean in order to get better processes, we try to do this last planner for sustainability related tasks. I hope you are, I guess you are familiar with the last planner method, but basically going back to what we just said about the fields and the experts, depending on the green feature that your bridge, your building, your road wants to get to fulfill, you will have different inputs from different fields. So the architect, the structural engineer, the mechanical, whatever. Okay, so each sustainability feature may have different inputs from different fields. So we said we need to know, everybody needs to know who does what, when, and what are the other one's needs. And this has to be constantly, possibly, if possible, visualized in order to know who's doing what. And so we linked, we thought about linking these things and these activities and these inputs and label them with a mark with the activity idea, so who does what when, linking the predecessor and successors, which are not strictly time related. The dependency, again, is not strictly time related, and then label them also through visual Kanban. Not only like the blue and red that you're seeing here, but to notify some what we call critical paths that are similar to the critical path of scheduling within project management. I will explain it in a second. And lastly, a list of constraints that will have to be technicians will have to focus them and solve them on a weekly and monthly basis. I just said about the visual Kanban and the constraints, and these thing we found that this thing works pretty well with the reference standards such as LEED and BREEAM. Why? Because these reference standards work through credits, and the credits, a lot of credits are linked with each other. So you are now seeing an example, and you are seeing the BREEAM, the first part of the BREEAM table for these credits. So you have the certification levels: pass, good, very good, excellent, outstanding, and then you have the issues or the credit. So the building feature that you have that you may want to have if you want to certify. So if you want an excellent level of certification, you do need the MAN04 credit. But if you want a very good, you don't need to. And these are just 3, but for each protocol, you have 20 to 30 different credits. And so we found within this last planner system, a good solution to keep this relationship with visualized and the constraints that are being solved throughout the process. We now step into the other section, so the practical implementation focus on procurement. And we are now I try to explain you our KPI